Hello there. In this lesson, we're going to talk about qualitative analysis, which is identifying something based on its qualities. So you can see the whole set of different substances here. You've got ions in solution, so various colors of ions you can use that could help you identify the ions by their color. And you also see different precipitates, right, that are also distinct from each other, right? Some of them are white, some of them are blue, some of them are black. You get all these different types of precipitates. And so either colors or precipitate or smell or any distinguishing characteristic is what we're going to use in order to narrow down options and to work out what ions might be present in a solution. So the different groupings that we're going to go through today are things that are either physical, like color and smell, and even density if you had the equipment for that. You can use these qualities to help you distinguish one substance from another and identify what it is. The other thing is we can use chemical properties, how these chemicals react with others, see whether a precipitate forms, see whether a gas is made, see whether pH changes. Any identifying new substance that shows up can help us to narrow down what might be present. Okay, so we'll start with solution colors. Most solutions, as you can see on this image from a shelf in a science lab, are colorless, right? No color, no color. But occasionally you get a couple that do have colors. And so knowing a few of the common colored ions can help you to narrow down or to identify right away ions that you might have. Now this is a little misleading because these bottles are frosted, and so it kind of alters the color of what's inside. The one here I believe is copper 2, and you would see a more bright blue if you poured it out into a test tube or a beaker. And the other one here I think is an iron 3 nitrate, which is this guy. So both of them you can use as use the color to identify ions in solution. Secondly, when you burn ions, they glow with a different color. This is the basis of things like different colored fireworks. And so one ion in solution might give you a red flame, while another one gives you more of an orange. I think this one is a lithium and this one is a sodium. And so you can use a flame test to tell right away the difference between certain ions in solution. Again, it doesn't work for everything, but for a bunch of them it does pretty well. Smells can also be used to identify certain compounds. If you have a cat or if you've ever been around people with cats, the place where they urinate tends to have a very strong smell. And that's usually due to a high concentration of urea that's in their urine. And urea decomposes, breaks down all by itself and produces ammonia gas. And that ammonia smell is what you smell. So ammonia has that distinct smell like cat pee or like afterbite or Windex because it's in all those products. So if you want to know if your solution has ammonium ions in it, you can react it out and get it to see if that gas is there, and you can smell to see if you got it. So let's say I have ammonium chloride in the solution. If I react it with, say, some sodium hydroxide, what will happen is that the sodium chloride will go together and you'll end up with ammonium hydroxide, which decomposes and gives you that ammonia that smells. Right, you get that very distinct smell. Another distinct smell that most people can identify is that of vinegar. And vinegar is due to acetate ions. So let's say you have some sodium acetate in a solution. And if you add any acid, so hydrochloric acid is an example, you'll end up with sodium chloride and then the ammonium, the acetic acid. And acetic acid is vinegar, or vinegar is just a dilute solution of acetic acid. So you'll definitely be able to smell that as well. So there's two very distinct smells that you can tell right away if they are a part of your mystery compound. Now, qualitative analysis is when you make more deliberate tests. You can do it as a spreadsheet or as a series of experiments that you might do to identify certain ions in solution. And what you do is you add your own separate compounds and you look for a precipitate. And if you get a precipitate, it'll tell you one thing, and if you don't get a precipitate, it would tell you another. So kind of like a little flow chart here, you can tell different things by whether or not you get a precipitate. So for this first one here, we're adding sodium chloride, and the sodium is group 1, so it's never going to precipitate with anything. So really, we're just adding chlorine. So chlorine doesn't precipitate with sodium. Chlorine doesn't precipitate. There's chlorine on our chart here. Chlorine doesn't precipitate with most things except silver, mercury 2, lead 2, and copper 1. So it will precipitate with this lead. So if it precipitates, you know you've got the lead in there. But if it doesn't precipitate, well, it must be one of these other two options, the sodium or the calcium. So once you do that test, and either you identify this or you rule it out, then you can do another test. If you still have a solution with no precipitate, you can then say, well, what if I added some sodium carbonate? Again, the sodium doesn't do anything because it's group 1. And so what if I add carbonate? So carbonate, down here, carbonate is insoluble with most things, but not with group 1. So if you got a precipitate, that would be the calcium because it is not in group 1. And if you didn't get a precipitate, well, it must be the sodium. So you can use a series of tests to help narrow down options starting from however many you have. This is just a small example using only 3 possibilities, but of course you can scale it up to make it as big as you want. So just a reminder there, I alluded to it in the previous slide. If you want to add a specific ion to a group, you can just find a compound that has either a group 1 ion, because those don't precipitate, or nitrate, because those don't precipitate either. So the little rhyme is group 1 and nitrates never form precipitates. So the example here is if I want to add iodide ions as a test, then I can use sodium iodide because it never forms precipitates. So really I'm just adding the iodide, and then I can see what will precipitate and the sodium won't interfere. If I wanted to add a copper to solution, well, I could use copper nitrate because nitrates don't form precipitates. So the nitrate wouldn't interfere with the copper in the test. Alrighty, so a few different conclusions you can come to depending on the results of your tests. First off, if you get a precipitate always means that something in that solution, formed an insoluble compound with what you added. And so you can always make conclusions that identify possibilities for that precipitate, what might be present. So here's an example. If I add some iodide ions and we got a precipitate, well, I know that iodide doesn't precipitate with most things, only with these, right? So our conclusion must be that either silver or mercury 2 or lead 2 or copper 1 must be present. So your conclusion is always going to be what is present. If you get no precipitate, you can make conclusions that eliminate options, because you can get rid of all the things that would have precipitated had they been there, right? So it's all about eliminating options when you have no precipitate. So in our example here, we have calcium ions added, and we got no precipitate. Well, since we're looking for stuff that actually is there, if no precipitate forms, we can eliminate all the things that should have precipitated. So we'll start with nitrates. Should a precipitate have formed? No. Acetate? No. Halides? No. Sulfates? Ooh, there's calcium. If the sulfate was there, it should have precipitated. So I can eliminate the sulfate ion, right? Because if it was there, it would have precipitated. Okay, so let's go down here. Sulfides, group 2, so that wouldn't precipitate. Carbonates, group 2 isn't an exception, so carbonates should have precipitated. And same with phosphates. So since we didn't get a precipitate, we can say no carbonates were in there and no phosphates either. Oh, 3+. And the last one here, hydroxide, looks like calcium is a precipitate, or is an exception for that, and would be insoluble, or sorry, soluble. And so that doesn't help us at all. But However, we got rid of 3 different ions just by having no precipitate in our test. Okay, let's put it all together and see if we can make some conclusions from these 2 tests. So we have a small pool here of 3 different ions. And so my first test is add some sodium and chlorine in there. Sodium doesn't react with anything, so really it's just the halogen that we're looking at here. There's chlorine, and we didn't get a precipitate. So if we didn't get a precipitate, it means none of these were in there. And which of these do we have on our list? Well, there's good old lead. So we can eliminate lead. Great. 1 down, 2 to go. Potassium sulfate is added. Again, potassium's group 1, we can ignore it, so it's really just sulfate is added, and we got a precipitate this time. So what would precipitate with sulfate? There it is, sulfates, and here are the possible precipitates over here, and magnesium's not there, but calcium is. So therefore, calcium must be present. Yay! Okay, so hopefully you got the basis of how qualitative analysis works, and we can do some practice and you can get better at doing your eliminating or finding things that are present.